So I don't usually do the whole little tool thing like a lot of people, but I did come across something so unusual that I have to show it. I don't know, a month or so ago on eBay, I was looking for dial indicators, particularly some Ames dial indicators, because I've had one since I learned how to start machining, and I don't know, I just kind of have a fondness for them. Anyway, I looked on eBay, and the ad on eBay showed just this little section right here. That'll show up. Anyway, it showed 1-inch travel, 5/10 resolution indicator, and it was like $30, something like that. But it says not original box. It's like, okay, but the indicator looked good, and that's what I really cared about, so that was fine. So I did buy it now, got a note from the seller a few minutes later that says there's a bunch of other stuff included with the indicator that he said he's been in the machinery business for 25 years. He had no idea what it was at all. He says, but you know, it's all, he goes, I didn't even take pictures of it because I didn't want to confuse the issue. He says, but I'll send it all to you, and it was the same price for the shipping and everything. So I open it up and I get this, which says Radi-ometer, and it's up here with a hyphen in it. It's got somebody's name on it, or serial tracking, whatever, purchase order. It's got it on the ends, both ends. It says, I think it shows up, radiometer. If you Google that, you come up with the little things that spin with light radiation from the sun. Somebody's radiometer, I can't think of the name right now, which, you know, is okay. So I did a lot of searching before I could fit. I mean, it was, you know, it's pretty obvious that the gauge goes into these pieces. There's a little slot in there. You set, it's got a set screw, and you can lock it down, and you zero it on this piece of granite a guy gave me. It's not as good as a surface plate, but it's good for a lot of things, including lapping. It's very flat, actually. Anyway, so that part's obvious, but how to use it really wasn't obvious. So I did enough Googling. I found a gauge that was somewhat like this, that was used for setting the curvature of blades on speed skates, because apparently, you know, at the high levels of that sport, like many others, every little detail matters. And this right here, I think you can read it. Let's see. It says, conversion book must stay with gauge. And I know why now. Because it's not hard math, but there's definitely math involved. So the way this works is that when you put the gauge in here, let me get the box out of the way now. So when the gauge goes in here, it's got a little notch, and it's not super critical where that goes, but you know, just get it in there so it doesn't move. Okay. There we go. So that locks it in there, and then I don't know if that'll show up or not. You know what? Let me lower the camera down so you can see this from the front. So anyway, the way this works is you put it on something very flat, and then you zero out the gauge. I'm going to turn it around real quick so I can see it. It wasn't actually quite in the slot. Hang on a second here. It's a little fussy. That's probably why they haven't used these in however many years. There we are. So we'll set the 0. Okay, so you can see that. So basically you lay this on something flat and set the 0. So what it is, let's see if this shows up at all. I don't know. Now it's down low and it's probably not going to. It might. I have to look. Hang on a second, let's check the camera. So anyway, it's a little circle geometry. So it turns out that this distance here is a very, very precise 4 inches, and there's another one that's 2 inches and another one that's 6 inches. So that forms A to B on a circle, which is the chord. So it turns out that it's not terribly difficult to do the math for this. So the line C to E, which is from the diameter to the other side of to where the chord intersects the circle or across the circle, is equal to the chord distance AB squared divided by 4 times the dimension from D to E, which is the outside of the circle to where the chord is, which is what this measures. So if you put this up against something round, it will displace the indicator plunger and measure the distance from the chord across the circle to the into the indicator. So that, because this is squared and divided by 4, it can be reduced so that you have, instead of doing, AB squared divided by 4 times that, you can do AB squared divided by 4 and just store that number and then divide that by the line, or the line of DE. So for the 2-inch version, that reduces to 1 over the line distance plus the line distance. The 4-inch one reduces to 4 divided by the line distance plus the line distance. And the 6-inch one, the 6-inch chord reduces to 9 over the line distance plus the line distance. So let me give you a little quick demonstration. And it's not as accurate as using proper measuring tools like micrometers and height gauges and all that. But for things that are hard to measure, like really big stuff or things you can't get to both sides, I could see where it'd be useful. It's certainly better than a tape measure. Anyway, let me make sure this shows up. Okay, this is an 8-inch lathe chuck. Just the one off my lathe. The jaws are out right now because I actually had taken it apart to clean it. But it worked out nice because it was a handy thing to measure. So if I put the gauge on here, I don't know if this will show up or not. It might. Let me do it on this side so you might be able to see it. I don't know if you can or not. But it's fussy, so you have to get it on there very straight and square. So I am reading, looks like 500. Make sure I'm not losing my mind. 500 and not quite 50. So it's looks like 545 and a half, almost 46 thousandths. So let's call it 0.546. So if we take and do 0.546, I don't know if that'll show up with white paper. So this is a 4-inch chord, so the math works out to 4 divided by 4 over 0.546 plus 0.546. So if we do that, you have 4 divided by 0.546. So I'll just write it all down. So 4 over 46 equals 7.326. So then we'd add plus 0.546. So anyway, the whole sum is 7.872 inches. So I actually previously measured this with my calipers, which are, they're pretty good. They're probably within a thousandth or so. And I got 7.879. So the calipers, .879. So, and this gauge is 7.872. So there is a difference. It's obviously 7 thousandths difference. Given the very small portion of the diameter that we're measuring, it's not too bad. It seems to get better on larger stuff, or at least using a larger cord, probably because the divisor's bigger. I measured my drill press column. I have an old Powermatic 1200 drill press. It mics at 3.9997, so it's 4-inch nominal, and it's very close. It's within a few tenths. With that one, I had to use a 2-inch cord version, and I ended up getting 3.986. So a difference of about, 14 thousandths, 13 thousandths, I think it was. I did let's show another one real quick. Hang on a second, let me grab it. So this is a brake rotor. It's actually brand new. I keep it around because it's machined on both sides and very flat. It's kind of handy for quick trimming of the mill. Anyway, I do not have a caliper big enough to measure this. However, I have a height gauge. And near as I can tell with the height gauge, it measures, wrote it down here, where did it go? I got 10.939 with my height gauge. So if we take our little Radi-ometer, I've got to find a part on here that's pretty smooth because it's got stampings on it and all that. So if we put this on there and measure it, get looks like 379 thousandths, because this is 50 thousandths per rev. I show 350 plus 29, so it's 379. It's a little bit like reading a micrometer. So for the caliper, we get 0.379. So if we go 4 divided by 0.379, we get 10.554 plus 0.379. $10.933. And the height gauge is 10.939. So again, it's a little bit off. So my height gauge, which is pretty good near as I can tell, it's an old Starrett vernier, but it's still really accurate. You put an accurate 1, 2, 3 block in there and it reads 2 inches on the 2-inch side. So that reads 10.939. With this, I get 10.933. So it's off 6 thousandths. But that's not too bad. I mean, a pie tape might be better if you can keep it absolutely straight. But when for small stuff like this, it's not very useful because you can get to it. But I used to work in a shop that we had things that were 120 inches in diameter. Now you're measuring, even with a 6-inch, when you're measuring a small part of the circle with only a 6-inch cord. But trying to get an accurate measurement on something that big, it's probably got quite a big tolerance. This actually might be pretty useful. Obviously, if you're measuring just the radius of some existing cover or thing that you have to match, it might be useful. I don't know how long ago these were made. I went to trade school to be a machinist starting in 1975. And I've never seen anything like this. The place I worked at right after that had been around since the late 1800s, and I never saw anything like this at that place. They may have had them, I just didn't see them if they did. So I don't know, maybe if somebody watches this and knows more about it, I'd love to know. It has also a couple of, get this out of the way. It has a couple of extensions, a 1 and a 2-inch extension, which are really accurate. And then you could take the cord here and measure the inside diameter of a big shell. That might be a lot more useful than measuring the outside diameter of things. But you know, for things that you can't get all the way around or get across, this would be really cool. Will I actually ever use this in real life? I don't know. I bought it for the indicator, but I love old tools. So I'm actually really glad I found it. It didn't go to the scrap yard. I don't know, like I said, that I'll ever use it, but it is very, very cool, at least in my mind. Anyway, my furnace just kicked on, and that's probably my sign to stop.